NIEM in Enterprise Architect. NIEM stands for National Information Exchange Model. It provides a means for describing the data that is being exchanged between organisations. This allows us to perform effective and efficient electronic transfer of critical information. On the left of screen, Organisation 1 uses the terms surname, gender and origin of birth, whereas Organisation 2 uses the terms last name, sex and nationality to describe the same data. NIEM defines a common vocabulary in order for these two organisations to effectively exchange data. Today we're going to demonstrate how to use Enterprise Architect to generate a NIEM IEPD. This consists of two fundamental steps. Create a NIEM model of the exchange and generate the IAPD using the built-in generation feature. The user guide example shown on screen shows in some detail the process of creating a subset of the NIEM reference model that is specific to our data exchange and defining the content of the XML document used for that exchange. We encourage you to review this topic to become familiar with the terminology and better understand the steps involved in creating a NIEM model and generating an IAPD. We begin the process with the UML model of our information exchange. Two classes are displayed on screen representing a facial image submitted for authentication and the system response consisting of a greeting and the name of the recognised person after successful authentication. The NIEM package will be used to construct our NIEM representation of this same information exchange. To use NIEM, we begin by selecting the NIEM perspective, which in turn opens the model wizard. For this exercise, we'll import the NIEM for reference model, the MPD types, and the IAPD starter model. Click on Create Patterns to import the selected packages. Importing the packages may take several minutes. We have imported the NIEM for reference model, MPD types, and the NIEM for starter model. Let's take a brief look at these now. The reference model contains data type definitions for describing just about anything. There are many packages aimed at specific domains such as agriculture or biometrics. When using NIEM, we usually create a subset of the reference model that uses just a small selection of the data types available. In our example, we'll have two information exchanges. The first contains a facial image and the second contains greeting text and a person's name. The reference model contains data types that we can use to describe the data contained in these messages. The domain package biometrics provides a face image type. We'll use this later when we create our subset. As you can see, there are many properties available in face image type. Most of these are not required in this example. The NIEM core package contains data types that are commonly used across all domains. Types such as activity type, address type, and person type, and text type. We'll include in our subset model the person name property from person type, as well as text type for use in our response message. We'll see how this is done later in the demonstration. The starter model provides a package structure that will hold the subset model. It also provides some placeholder elements for defining a message exchange and a number of object instances of MDP types that are used to drive the IAPD generation process, as well as provide much of the information such as the URIs and target namespaces specific to our IAPD. You'll need to provide these values yourself, overriding the existing default values. Before we begin the process of creating a NIEM subset model, we refer back to our UML model of the information to be exchanged. We have two classes, one representing the authentication request and a second representing the authentication response. The request consists of just a facial image, whilst the response consists of some greeting text and the name of the recognised person. To create the NIEM subset model, we'll use Enterprise Architect Schema Composer. This is accessed from the Specialised ribbon as shown on screen. The first thing we must do is create a new schema profile. We click on New and then select Model Transform. We provide a name, Authentication Exchange, and choose a schema set from the drop-down list. Select the option NIEM for this field. The namespace field is left blank as the namespace is specified in the tagged values of the package NPD exchange. We'll save the schema profile as a model artifact, placing it in the package NIEM starter model. We can see the new schema profile artifact in the project browser. We start the process of subsetting by selecting a data type to represent the facial image. A suitable type can be found in the domains package biometrics. If we scroll down, we find the type face image type. You'll soon get to know where to look for the data types you need. You can also use EA's search capabilities to find what you need. To select the type, simply drag it from the project browser into the classes column of the schema composer. When face image type is dropped onto the schema composer, all of the base types from which it is derived are automatically added as well. You can see on screen that 2 image types have been added, as well as a binary type. Face image type is derived from biometrics image type, which in turn is derived from NIEM core image type, and that is derived from NIEM core binary type. The attributes column shows the properties of the selected classes, as well as its inheritance chain and associations to other classes. The next step is to choose specific properties of the selected data types that you want to include in the subset model. As you can see on screen, face image type has quite a few properties such as person eye color and person hair color. For this example, we're selecting face image feature point. Once this is selected, the type of the property, face image feature point type, is automatically added to the list of selected classes. When this type is selected in the classes column, its properties are then displayed in the attributes column. We further select the properties feature point horizontal coordinate value and feature point vertical coordinate value. Both of these properties are of type decimal. Decimal is a primitive type, and as such, it is not added to the list of selected classes. Ultimately, we want to transmit a binary object that is the facial image. So select binary type in the classes column, then select its property, binary object abstract. A binary object abstract property holder is added to the classes list. When you select this property holder in the classes list, you should notice that its property, binary object abstract, is pre-selected. This abstract property is referenced by the property of the same name in binary type. The abstract property in binary type will be substituted by a real type selected from the property holder. We select base64 binary object. This specifies the data type used to store and send the facial image captured by the system. We'll also select the binary type property binary capture date, which adds the type date type, then use the date representation property holder to specify the property date, which is of type date, a primitive type. For the response message, we need to select a text type and person name type. Both of these can be found in the package NIEM core. Text type is a simple type defined within NIEM core. Simple types are listed after the complex types at the bottom of the list of types. Person name is a property that can be found within person type. Selecting person name will add the type person name type to the list of selected classes. From person name type, you can then select the properties person given name, person middle name, and person surname. These 3 properties are all of type person name text type. Person name text type inherits from proper name text type, and finally string, which is a primitive type. The selections we have made can be saved to the Schema Composer profile artifact by clicking on Update. The artifact can then be reloaded later if we discover that we need to make changes to our selections. In the schema panel on the right of screen, the selected data types and their selected properties can be seen. This shows you what will be included in the model transform when the subset model is generated. We are now ready to generate our subset model using the selections we have made. The generation process will create a number of new packages, applying the information model stereotype as needed, before copying the data types and properties we selected into those packages. We'll use the package NIEM4StarterModel as a target for the generated output. To generate, we simply click on the Generate button. We choose the option NIEM Model Subset, then click on Generate. Now we choose a parent package for the generated output, choose NIEM4StarterModel, and click OK. We now have a domains package, and within that a biome package. The biome package contains cut-down versions of face image type, face image feature point type, and image type. We also have a NIEM core package that contains cut-down versions of binary type, person name type, and various other supporting data types. This is our subset model. What we see in the project browser corresponds to what we see in the schema panel of the Schema Composer. To learn more about how to use the Schema Composer to create subset models using NIEM's modelling techniques, please refer to the 3 walkthrough examples in the Enterprise Architect User Guide. Find the topic Subsetting NIEM with the Schema Composer and look for the link in the Learn More section. We'll now begin to tailor the provided NPD exchange package to our specific data exchange. We start by renaming the property holder, properties and data types that appear on the diagram NPD exchange. Using the Properties window is the easiest way to do this. The message itself is modelled as an association end, so double-click on the connector to access the target role information. Our example IAPD describes 2 messages, a request and the corresponding response. So far we've described the request. Now we need to add some elements to describe the response. Open the diagram toolbox. The diagram is a NIEM PIM diagram, so the toolbox shows corresponding NIEM profile elements. Place onto the diagram a new property holder and object type. Then drag an association from the property holder to the object type. We'll give these items names that are appropriate for the response message. Here are the additional elements with the names appropriate for the response message. The diagram NPD overview that is part of the NIEM4StarterModel shows the package usage for the information model package NPD exchange. We now have 2 additional information model packages in our model that were created when we generated the subset model. They are NIEM Core and Biometrics. Let's create a new diagram that shows the usage of all of the information model packages in our model. Create a new NIEM NPD diagram and name it Package Usage. First, we drop onto the diagram the instance of the model package description named NIEM NPD. Then we drop onto the diagram each of the information model packages in our model. Drop these as package elements. If we now open the Tagged Values window, we can inspect the tagged values associated with each of the packages, but also the tagged values specified by the usage connectors themselves. The path for the XSD schema file that will be generated from this package is specified in these tagged values. The subsetting process has filled in a value for us, but we can override it if we choose to. The NIEM4StarterModel provides us with a definition for one document root element, but in this example we need to specify 2 document root elements, one for each message. On screen we can see that the object instance of qualified names type named validity constraint with context is linked to the authentication request property holder by a usage connector stereotyped with qualified name. We'll create a new diagram that focuses on specifying only the document root elements. So, create a new NIEM IEPD diagram and name it Document Roots. From the project browser, we drop onto the diagram the existing NIEM IEPD instance. We also drop on the existing nested object instances of IAP, conformance target type and qualified names type. Then we drop on to the diagram the existing authentication request property holder. The existing usage connector is added automatically. These are the items that were already provided by the starter model. Now we will create a second set of these items. We expand the package NIEM IEPD types in the project browser. Then we place additional object instances of the types IAP conformance target type and qualified names type onto the diagram, and nest them within the instance of model package description in the same way that the existing ones are. Now we can drag the authentication response property holder onto the diagram as a link, and finally we connect the instance of qualified names type to authentication response property holder using a qualified name connector selected from the toolbox. We've now defined both of our document root elements, but if we open the diagram MPD Exchange, we can see that both of the types, authentication request message type and authentication response message type, have no attributes. At this stage, both of our messages are still empty. We need to add some properties to each of these types. We open the attributes window, then select authentication request message type, add a new attribute named facial image, and select the type as face image type from our subset package biome. Select authentication response message type and add a new attribute named recognize person and select the person type from the subset package NIEM core. Add a second attribute named greeting text and select the type as text type, again from the subset package NIEM core. We are almost ready to generate the IAPD. We just need to rename the instance of the model package description using a name appropriate to our example. This name is used within the IAPD and is also the name used for the root folder that will contain all of the generated output. Now select the instance of the model package description and invoke the generate command. The dialog allows you to review or specify what will be generated. Specify the output folder and click on Generate. We can now see the progress in the system output window. Once the generation is complete, we can inspect the generated output. The schema files are generated into a predefined folder structure, with schema files for the subset schema under the NIEM folder and the extension schema files specific to our example under the extension folder. A catalog file is also generated specifying all of the files that make up the IAPD. Switching to Enterprise Architect, we can view the XSD files to see what has been produced. From the code ribbon, select Edit, Open Source File to open the XSD files in the editor. If we open the extension file mpdexchange.xsd, we can see the two message elements defined in the file. They are authentication request message and authentication response message. The type definitions for these elements are included in this file. We can see the authentication request message type contains one element, the facial image, that is defined as being a biometrics face image type. We also see the authentication response message type that contains two elements being greeting text and recognized person. These are both defined as NIEM core types being text type and person type. Likewise, the NIEM subset files contain the elements and type definitions that are referenced by our extension file. Finally, we can examine the MPD catalog file, which is a table of contents of what is contained in the IAPD. For more information about NIEM or Enterprise Architect, please visit www.sparxsystems.com.